Construction began a decade ago, but had long since been abandoned. Once completed, this tower is set to surpass the current record holder, the Burj Khalifa Tower in Dubai. The exact height of the Jeddah Tower is not yet known, but it is expected to rise at least 1,007 meters above the port city of Jeddah. According to Middle East Business Intelligence, a number of companies have been approached to take over this mega project. Among the names mentioned by the media report is the Swedish construction company Skanska, as well as Samsung's Korean engineering and construction subsidiary. But even if work does get underway, completion of the Jeddah Tower is far from guaranteed, as surpassing the symbolic 1-kilometer height mark is an unprecedented challenge in the history of construction. Between ambition and reality, many challenges will have to be overcome, and some professionals in the sector are still wondering whether it is really feasible. The stability of the structure, its resistance to wind, and even the building materials to be used to make the skyscraper sustainable are all technical challenges that will have to be met, and that's what we're going to find out right now in this video. The first challenge of such a construction is stability. Indeed, the taller the skyscraper, the more it is subjected to the effects of wind and the stresses generated by the weight of the building on the base of its structure. With a height equivalent to more than 3 Eiffel Towers and a weight of 900,000 tons, the equivalent of the Golden Gate Bridge, it becomes necessary to plan a form and foundations that will be adapted to the scale of the building. Adrian Smith's team, therefore, proposed an asymmetrical Y-shaped tower close to the silhouette of the Burj Khalifa. The reason for this tripod shape is that it is the best way to reach such a height. Like a spinal column, it enables a rigid pillar to be placed at the center of the superstructure, guaranteeing excellent stability while limiting the quantity of materials used. Finally, to anchor the tower solidly without having to dig too deep, the ground must be made up of stable rock on which the building structure can rest. All the more so in Jeddah, where the soil is largely made up of friable limestone, sand, and gravel. Extensive geological studies were therefore required to determine the depth at which the tower could be safely supported. As a result, 270 pillars made of high-performance concrete capable of withstanding strong compression were planted in the ground at depths of between 50 and 110 meters. According to the person in charge of the operation, this was a complex and unprecedented drilling technique. By way of comparison, the foundations of the Empire State Building go down to a depth of 17 meters, and those of the Burj Khalifa to 50 meters. In some places, therefore, they are twice as deep as those of the world's tallest skyscraper, and this first phase of the project, which began in June 2013, mobilized no fewer than 100 workers who worked in shifts 24 hours a day, 6 days a week for 6 months. The second challenge for the Jeddah Tower is the choice of materials to be used to make it both solid and economically viable. On this site, the client imposed the use of traditional materials such as conventional concrete, as it is less costly and easier to lay than high-performance concrete, which requires specially trained workers. With this cost-effectiveness in mind, Adrian Smith's architects opted for a tried-and-tested engineering solution: reinforced concrete walls. However, another major constraint arises when it comes to erecting such a tall skyscraper: the challenge of transporting concrete to such heights. At present, the best pumps on the market operate at a pressure of 250 bars and can deliver concrete up to 500 meters high, but not beyond. If you want to go higher, you have to transport it in buckets attached to cranes, which slows down and complicates operations considerably. It's for this reason that most megatall skyscrapers have their upper parts made of steel. With this in mind, Adrian Smith's team decided to build the upper section in steel, as was done for the Burj Khalifa. This upper part will no longer be inhabited and will simply be a gigantic 350-meter-long ornamental spire housing the tower's technical facilities. The same applies to the world's highest observation deck at 630 meters above sea level, reminiscent of the 30 Hudson Yards in New York and the Burj Al Arab in Dubai. In all, no less than 500,000 cubic meters of concrete and almost 80,000 tons of steel will be required to build the Jeddah Tower, which is quite a considerable amount. By way of comparison, 80,000 tons of steel is the weight of 10 steel structures, such as the Eiffel Tower. When it comes to high-rise buildings, there's a major parameter to take into account: the structure's resistance to the forces exerted by the wind, and as we all know, these forces are amplified the higher you go. For example, a 500-meter skyscraper must be 60 times more wind-resistant than a 60-meter building. This calls for a special bracing structure to keep the tower as stable as possible and to prevent occupants from feeling the building's oscillations. The project's architects and engineers use computer and model simulations to model the forces of wind on the structure of the Jeddah Tower. In the end, these simulations showed that in the event of strong winds, the top of the tower could move up to 2 meters in relation to its axis. But according to Adrian Smith's team, these punctual oscillations would be acceptable for the structure of the tower and the comfort of its occupants. To avoid such a large tower becoming an energy sink, it quickly became essential to limit the use of air conditioning, especially in a country as hot as Saudi Arabia. The tower was therefore designed with energy efficiency in mind, in such a way as to be able to regulate itself thermally, notably by playing on shadows. To achieve this, the sun's path around the building was modeled to identify which areas were most exposed to the sun throughout the day. This made it possible to understand where it was appropriate to create shadow zones on the tower's facades. For this reason, notches were drawn on the building's facade. By casting their shadows onto the adjacent walls at different times of the day, they helped to protect the tower from the sun and even act as a terrace for future occupants. In addition to this, the exterior glass walls were designed to be as insulating as possible, using low emissivity glass covered with a filter that effectively blocks infrared radiation, the source of heat propagation. With a total of 530 apartments, 200 hotel rooms, and an observation terrace that will be the highest ever built, the Jeddah Tower will be a veritable vertical city to which mobility will have to be adapted accordingly. To best serve the 530,000 square meters of available space and the tower's 167 floors, a veritable army of 57 elevators is planned. Their speed is designed to reach 10 meters per second, which is optimal to avoid discomfort during the acceleration phase. But at this speed alone, it will take just 98 seconds, including loading time, to reach the top floors of the tower, which is already very fast. To install all these elevators, heavy-duty cables capable of stretching over 600 meters will have to be used. To achieve this, a new carbon fiber cable technology was chosen, as steel cables are too heavy to be used above 500 meters. Not only are they stronger, they also last twice as long. They also reduce the weight of the total load to be lifted, including cabins and elevator cables. Thanks to this technology, each elevator will be able to carry 26 people, representing a load of 2 tons. With traditional steel cabling, this would be equivalent to lifting 27 tons or the weight of a truck. The Jeddah Tower embodies the desire to set a new world record for the world's tallest skyscraper and illustrates the ambition of today's architects and contractors to be ever more competitive. However, one wonders whether these new records will continue to follow one another. Will we soon reach the limit of what human beings are capable of building? For some architects, such as Jérôme Kiévreux, a French specialist in high-rise buildings, the question is worth asking. In his view, building sites above 1,500 meters will quickly become complicated, if not impossible. Not only will it be necessary to find ultra-solid ground to anchor the foundations of these gigantic towers, but also the financial resources to build and maintain them. In his opinion, the Burj Khalifa is a good example of the resources required to build at such heights. A site costing over $1.5 billion, 22 million man-hours, and up to 7,500 employees at its peak. For lighting, air conditioning, and elevator operation alone, the Burj Khalifa requires 36 megawatts of power at peak times, equivalent to the consumption of an average city of 80,000 inhabitants, while the building has a maximum occupancy of 35,000. And for the record, it takes a whopping 4 months to clean the entire 120,000 square meters of glass facades. These figures are literally dizzying, and we're only talking about an 828-meter tower. Even if the desire to set new records is still very strong for some companies, few of them will really want to embark on such constructions, given the financial resources involved. On the other hand, one thing is certain. If the race to the sky is to continue, it will most certainly be in the countries of the Middle East and Asia, where competition between these regions of the globe is raging and should continue to foster the effervescence of these mega projects for at least a few decades to come. That's the end of this video. I hope you enjoyed it. If you did, don't forget to give a like and subscribe to the channel. Thank you for watching and see you soon on Looking For. Goodbye.